So today's video we are going to discuss some of the problems of de Moivre's theorem. So in the last class we have discussed that if n is any positive or negative integer or fraction, then cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. The first problem is, if alpha is equal to 15 degree, find the value of cos alpha plus I sin alpha, cos 2 alpha plus I sin 2 alpha divided by cos 3 alpha minus I sin 3 alpha. So first we have to solve it using trigonometrical formula, and then we will use the de Moivre's theorem. So it is given that I sin 3 alpha. We know that if a function is divided by 1 by x and if the function comes to numerator, then we have x to the power minus 1. So in this case, I sin alpha cos 2 alpha plus I sin 2 alpha cos 3 alpha minus I sin 3 alpha. Next, cos alpha plus I sin alpha to the power minus 1, cos 2 alpha plus I sin 2 alpha. Here on the using the property we get cos minus of 3 alpha I sin minus of 3 alpha. Using the property of cos and sine angle, cos minus of theta is equal to cos theta, sine minus of theta is equal to minus sine theta. So in this case, cos minus of 3 alpha is equal to plus cos 3 alpha, and sine minus of 3 alpha is equal to minus sine 3 alpha. So minus minus plus. So in the next line it is cos 2 alpha plus I sin 2 alpha cos 3 alpha minus minus plus I sin 3 alpha. While proving the de Moivre's theorem, we have seen that if 3 terms are there or 4 terms are there with the same number of angles, we can write it cos alpha plus 2 alpha plus 3 alpha plus I times sine alpha plus 2 alpha plus 3 alpha. 3 plus 2 is equal to 5 plus 1 is equal to 6. So cos 6 alpha plus I sin 6 alpha. What is the value of alpha? Alpha is equal to 15 degree. So cos 6 into 15 plus I sin 6 into 15. So it is cos 90 degree. Cos 90 degree plus I sin 90 degree. Cos 90 degree is 0 and sin 90 degree is 1. So this value of this equation is I. Now using de Moivre's theorem, we can easily solve this. So the value of the above equation is plus I. The next problem is, if cos is equal to x is equal to cos alpha plus I sin alpha, and y is equal to cos beta plus I sin beta, and z is equal to cos gamma plus I sin gamma, and if x plus y plus z is equal to 0, then prove that 1 by x plus 1 by y plus 1 by z is equal to 0. So it is given x plus y plus z is equal to 0. Now substituting the value of x, y and z, cos alpha plus I sin alpha plus cos beta plus I sin beta, cos gamma plus I sin gamma is equal to 0. Now writing the real part in the one bracket and imaginary part in the other bracket, is equal to 0. Is 0, this can be written as 0 plus I times 0. So comparing real and imaginary part, cos alpha plus I cos beta plus cos gamma is equal to 0, and sin alpha plus sin beta plus sin gamma is equal to 0. Now we have to prove that 1 by x plus 1 by y plus 1 by z is equal to 0. So LHS 1 by x plus 1 by y plus 1 by z. 1 by x means x to the power minus 1. 1 by y is equal to y to the power minus 1, and 1 by z is equal to z to the power minus 1. Now substituting the value of x, y and z, we have cos alpha plus I sin alpha to the power minus 1 plus cos beta plus I sin beta to the power minus 1 plus cos gamma plus I sin gamma to the power minus 1. So as we know that using the de Moivre's theorem, this is cos minus of alpha plus I sin minus of alpha, cos minus of beta I sin minus of beta, cos minus of gamma plus I sin minus of gamma. Cos minus of theta is equal to plus theta cos theta, and sin minus of theta is equal to minus sin theta. So this is cos alpha minus I sin alpha, cos beta minus I sin beta, cos gamma minus I sin gamma. Now writing the real part, taking minus I as a common, sin alpha plus sin beta plus sin gamma. Now we have already proved that cos alpha plus cos beta plus cos gamma is equal to 0, and sin alpha plus sin beta plus sin gamma is equal to 0. If we take it as equation 1, so it is 0 and minus 0 using 1, so it is 0, which is equal to RHS. So that's why the easy process to solve the any identity or equation by using de Moivre's theorem.